This is lesson 4, inverse functions. The inverse of a function performs the opposite operation to the original function. It takes elements from the range of the original function, which is all the values of what the function can be, and then maps them to the elements in the domain of the original function, so all the values that x can take. They only exist for one-to-one functions because of this. So this means f of x and f to the minus 1 of x are inverses of each other. This is the inverse of f of x, is written with a minus 1. This also means that f of the inverse of x is equal to the inverse of f of x, which will just give you x. The graphs y equals f of x and y equals the inverse of x are just reflections of each other in the line y equals x. The domain of f of x will be equal to the range of its inverse, and the range of f of x will be the domain of its inverse. Let's do an example. Let's find the inverse of h of x equals 2x squared minus 7. To get from x to 2x squared minus 7, we first square it, then times by 2, and then we minus 7. So to go backwards, if we start from x, we need to add 7, then divide by 2, and then square root it. The range of h of x is bigger than or equal to minus 7. So the domain of h1, the inverse h of x, is x is greater than or equal to minus 7. This means that the inverse of h of x is the square root of x plus 7 over 2 for the domain x is greater than or equal to minus 7. Let's do one more example. We have f of x equals x squared minus 3 for real values of x and x is greater than or equal to 0. A. Find the inverse of f. B. Sketch y equals inverse of f of x. And C. Solve f of x equals inverse of f. Part A. Let's let y equals f of x. So y equals x squared minus 3. Then rearranging, we get y plus 3 equals x squared. So x equals square root of y plus 3. This means that the inverse of x equals the square root of x plus 3 for real values of x. And don't forget, the range of this function will be f of x is greater than or equal to minus 3. So that means x is greater than or equal to minus 3. For part B, let's start with the graphs y equals f of x and y equals x. We know that the inverse will be a reflection of this in the line y equals x. So let's start at x minus 3, and it will look like a reflection intersecting at the line y equals x. For part C, we are solving f of x equals the inverse f of x. When f of x equals the inverse of x, as you saw in the graph, f of x equals to x because they intersect on the line y equals x. So we can say x squared minus 3 equals x squared minus x minus 3 equals 0. And using the quadratic formula, we get x equals 1 plus square root of 13 over 2. It's not going to be 1 minus square root of 13 over 2 because it's only defined for x is bigger than or equal to 0. And that's it.